Hey guys, welcome back. So today we're going to be focusing on primarily writing formulas. This is going to be a little more difficult than what we did the other day, okay? So the other day all we were focused on were naming, writing the names of common ionic formulas, right? Okay, so now we're going to be looking at the charges. Now I tried to show you a little bit about the charges the day before, but we're not really going to get into that until just today. So when you're looking at this, you're going to identify the cation and the anion, okay? So remember, the cation is always written first, the anion is going to be written second. Then you will balance out your charges. Remember, they have to be electrically neutral, so they have to equal 0, okay? Then you will write the formula cation first using subscripts from the charge balance, okay? All right, so guide to writing formulas from the name. So to write the formula of a binary compound, first write the symbol of the cation and then the anion, okay? Then add subscripts as needed to balance the charges. The positive charge of the cation must balance the negative charge of the anion so that the net ionic charge of the formula is 0. For example, the ionic compound potassium chloride is composed of potassium cations. So we know that potassium is a positive 1, okay? And chloride is a Cl minus 1. So potassium chloride is a binary ionic compound. So you would write it like this, and you would write K positive and Cl minus. Now, as you can see, a plus 1 and a minus 1 equals 0. So now I just have to drop my charges and drop this down and write it as KCl. The ions combine in a 1-to-1 ratio, okay? Now, if I'm looking at copper and sulfur, even though it's a plus 2 and a minus 2, the sum of the two equals 0. Now, people have a tendency when they drop this down to write Cu2 and S2. You don't do that. When they cancel out, you're just writing how many atoms you used to cancel the charges out. Well, it was a 1-to-1 ratio. So we used 1 copper to cancel out 1 sulfur. Okay, so in saying that, when you write the formula, it's going to be CUS. So you don't write any subscripts. Remember, 1 is always understood, kind of like in math, when you write x plus something, right? X plus 5. So you don't write 1x. Remember, the 1 is understood. You only write 2 and higher, okay? So in our purposes here, because those charges canceled out, it's a 1-to-1 ratio. So I need 1 copper to cancel 1 sulfur out, okay? So that's why you don't write anything as subscripts. Now, when you have compounds having different oxidation numbers, okay, you'll write the symbols of the elements listing the positive ion first. So iron 3 oxide contains Fe plus 3. Cations combine with oxide anions, which are -2. So to balance a plus 3 and a -2 charge, you must find the least common multiple of the charges, which is 6. Okay, so we all know that the common multiple between 3 and 2 is 6. So how would I make those charges both 6? Okay, well, let's see. So 2 iron ions would equal a plus 6 charge, and 3 oxygen ions or oxide ions would equal a minus 6 charge. So when we write the balance formula, it's going to be 2 irons and 3 oxygens to balance out those charges. You're trying to get the charges to be the same number. A plus and a minus have to equal 0, okay? So you want them to be the same number. So you're going to find the least common multiple to get to that number, okay? So another approach to writing a balance formula for a compound is use what we call the crisscross method. Now, in the crisscross method, the numerical value of the charge of each ion is crossed over and becomes the subscript for the other ion. So we call it the crisscross method, right? So you're going down, from the top down. You drop your charge and you crisscross down. So what happens is the 3 from the Fe goes to the oxygen, and the 2 from the oxygen goes to the Fe. So now when you write it, you have Fe2O3. That's another way to look at it. So you can either do what we call before, balance out the charges, or use the crisscross method and cross the numbers. Remember though, a lot of times people get confused because you're not supposed to write the 1. So sometimes when you're doing that crisscross method, people get confused to not drop that 1. So it's important that you remember the 1 is always dropped. Okay? So let's look at our charges here. Okay? Sodium and bromine, sodium and sulfide, sodium and nitrogen. Then you have aluminum and bromine or bromide, aluminum and sulfide, and aluminum and nitride. Okay? So as you can see with these charges, the 1 and the 1 from the sodium and bromide will cancel out. So you just write NaBr. Okay? When you have the sodium to the sulfide, if you use the crisscross method, the 2 goes to the sodium and the 1 goes to the sulfide. Remember, not writing the 1, okay? Or you could have just said least common multiples. It takes 2 of these to cancel out 1 of those, okay? And then the last one, you have sodium combining with nitride. You need 3 sodiums to cancel 1 nitride out. Or you could do the crisscross method, where you cross the numbers, okay? Next, you have aluminum and bromide. Aluminum's a 3, bromide is a -1. So it's going to take 3 bromines to cancel out 1 aluminum. So your formula will be AlBr3. Then you have aluminum and sulfur here, okay? What's common between 3 and 2? 6. So how would I make aluminum have a +6 charge? I'm going to need 2 of them. So that's where the Al2 comes into play. Sulfur, I have 2 of them. How would I make that 6? By timesing it by 3. So I need 3 sulfurs to make a -6. So that's where the 3 sulfurs come into play. And then finally, I have a +3 and a -3. They equal 0, they'll cancel out. So I need 1 of each to cancel it out. So it's Aln, okay? So that's an example of how you would write formulas. Okay? Now, we will be talking later about transition metals and how they form positive ions. But today we're just focusing on binary ionic compounds. So now your next activity is going to be where you're going to be writing common binary ionic formulas, okay? And then the next day, we're going to do a combined worksheet where you're going to do naming and writing on the same page, okay? So I'll see you later when we get to talking about transition metals, okay? Thank you.